Good afternoon, everyone. Can you guys hear me? Okay. So hopefully I had a good lunch, and this is going to be a tough session because you're all completely relaxed. So I'm going to spend some time going over 3GPP, introduce 3GPP, which is kind of weird because we've been talking about 3GPP for the past 2 days, so you probably know a lot more about it. But I'll get into some more details, a little bit more details, and maybe you don't know. Okay, so we'll do that. So one quick thing about myself, like when I it's a side note, like when I started my career, my first job, I was directly involved with Ethernet standardization. So an opportunity to work on. The company was making Ethernet transceivers, so I had the opportunity to go to IEEE meetings. And at that time, I did not realize the kind of impact, whatever work that we did. But now, there are billions of devices use the kind of technology that we worked on at that time. Like it's quite a while back when I had a lot of hair, more than what I have right now. So anyway, just a quick side note there. So what we'll cover today is like we'll introduce 3GPP, the process, what happens, how do standardization happens within 3GPP, and then we'll follow it up with a specific example on if you actually have something, a submission, what should you do? We'll get into some of the details in terms of how do you start off doing that. Okay. Hey, Vishnu and Jishnu, you guys need to come and sit there. You're not there when we called you. Okay, so what is 3GPP? You guys probably know this. I mean, maybe you didn't know, when did it started, right? It's about 1998, right? At that time, it was started as aim to standardize 3G phone specification, which running over at that time was GSM. So the original scope was just 2G and 3G, right? Later on, they went and modified it to include 4G and 4G and beyond, right? So the scope actually got modified later on. Okay, so some more details. I'm not going to go through every single thing here, but fact is there are a whole bunch of companies participating in it. It says 760 plus companies here. I'm pretty sure it's outdated. It's already gone much beyond that. Okay, and so what you see, all these releases like release 18, release 19, that happens like every 15 to 24 months on an average, give or take. And a new generation happens every decade. That's been the trend so far, right? So hopefully you're going to see 6G, pretty soon. So they cover all different features. Each release is actually self-contained, meaning you actually develop a product with one particular release. And when a subsequent release happens, they actually add additional features on it. Okay, so that's how it works. And most importantly, one thing is like, it's contribution driven and consensus based. And it's a pretty important point because everybody has to agree, right? So imagine so many members, so many contributions, so many groups, everyone trying to come together and so that everyone agrees and everybody has their own charter, obviously, right? They probably have their own IP, they want to push it through. There's a lot of vested interest at the end of the day. And imagine the amount of work that it takes to come up with something which everyone agrees, right? Most of the time I find it difficult to agree with my wife, right? So this is a complicated process. So in terms of the groups, there is a project coordination group right on top, which kind of sets the whole coordination and management. And within that, you got the RAN, CT, and the SA. The RAN pretty much covers everything from the mobile tower all the way to the cell devices. And CT is the core, right, where it controls how the devices actually, the subscription, how they, as they traverse through the network, how they are managed, the connection between the cell towers and all that stuff. And the service aspects, all the different service layers, which goes on top of that, okay? So you got the TSGs are organized into working groups. The working groups is where the actual work happens, okay, where all people get together in a room and they actually make a contribution. The contribution is typically like 2 minutes. They have to put if you have an idea, you have to make a presentation and then put it up. And typically, most people would have already seen the presentation. So once you do the 2-minute presentation, people are going to line up and ask questions on it, and they can put their own point forth in terms of disagreements and everything, right? So if everybody disagrees with something, the chair would say like, hey, go out, find a room, talk among yourselves and come back, right? So they have to then come up with a consensus and come back and do it, right? And it's actually a pretty healthy process at the end of the day, right? Some people may not get what they want, but at the end of the day, you want to come up with something that everybody is comfortable with implementing it so that everybody works with everybody else, right? So the TSG meets 4 times a year, called plenary meetings, and the work groups happen between the TSG meeting. For example, there is a work group, CT work group meeting that's going to happen in Hyderabad this month, I think. And then there is a TSG meeting happening in Shanghai right after that, right? So a lot of activities. Okay, let's go to the next one. We talked about that, and the project coordination groups right on top. That's the one which kind of schedules in terms of who's going to do what and things like that. And the TSG meetings happen in parallel. And as I said, they meet 4 times in a year, March, June, September, and December. They can approve their own specs. And the work group meetings, sometimes once, sometimes twice, but happens between the TSGs. Okay, so organizational partners. This kind of gives you an idea in terms of how the organizational partners work with the GPP, right? So you could see TSDSI is one of the organizational partner. So one important thing which is important to note, which you may not be aware of, is like they develop technical specification, right? We take the spec, we adopt it, then it becomes a standard, right? So there's a slight distinction there. And of course, there is an IPR policy, which everybody has to adhere to, and we'll talk some more about that. I mean, individual members should declare the earliest opportunity, any IPRs they believe to be essential. You would have probably heard the term standard essential pattern. Apparently, it was discussed quite a bit yesterday, right? So, and the declaration should be made by the individual members to the respective organizational partners, okay? And of course, we encourage the members to grant licenses on FRAND terms, right, which is fair, reasonable terms and conditions. Okay, so I'm not going to get too much into details on this because my previous speakers did a much better job in actually going into all the details. So it kind of shows you. I talked about the releases that happening every every couple of years or so. So it kind of shows, and this is sort of like the latest. And there is a plan to see what all happens even beyond 2024, and you can see that here. And what you see on the top, the numbers, those are all the plenary meetings that happens. And you could see that everything is all like pre-scheduled, well organized. Okay. Okay, let me skip that. A quick point on that. I mean, once you, just to give you a nomenclature, by the way, all this documentation is available, so you should be able to use it for reference. So the first 2 digits represents in terms of what the spec is all about, right? In terms of the broader functional description, right? And then there is this 3 digits following that, and the first digit it kind of tells like 1 means is presented for information, 2 means is presented for approval, 3 or greater indicates that the TSG approved document is under change control, right? And the second digit is incremented for all changes of substance, like any kind of technical revisions, it gets incremented. The third digit is editorial, right? So when you go into the TGPP website and see all these numbers, you will, by looking at these numbers, you'll get an idea in terms of what this is all about. Okay. So, um, so in terms of, I'm trying to break this down, simplify the whole process in terms of what happens, right? So typically, there is an early R&D, which pretty much you have an idea in terms of what you want to standardize and stuff. So you go and do some more work on it, come up with a spec, and then make a presentation, things like that. And that becomes a project proposal. And then it moves into a study item, right, where you get into some more details. And for each of these steps, there are a bunch of, everybody has to make a submission, right? You have to actually go and explain exactly why you're doing it and what are the merits of it, right? And then it becomes a work item, and finally it becomes a spec. It's kind of a gradual progression, okay? So this is the early R&D. You define the need. You have to, at that time, obviously your idea has to have a market requirement. It has to make sense. Like, somebody has to accept it, right? It cannot be some random feature, right? You may have to build, prototype, validate the concept. You do a lot of that early work. Again, project proposal stage inside 3GPP. You make a new feature request, can come from any member, but it should have a support of at least the 4 other members, okay? And usually cited over multiple meetings, and the TSG either approves it or abandons or holds or reiterate, can tell, like, go back and make some changes and come back, right? So then they have to go back to the drawing board. Study item stage, again, as you go through all these stages, it gets much more in depth, right? There's a lot more details that you have to hash out, right? So very similar. Again, this becomes a little bit more technical, right? There is something called a TDoc, which gets submitted. If you go into the 3GPP website, you can see a bunch of TDocs there, okay? And work item, similar, iterative, contribution-driven, consensus-based process followed, right? So towards this, when it gets into this work item stage, pretty much you can see that people have broadly agreed to something, right? So it kind of, you're getting into the nuts and bolts, you're dotting the I's, crossing the T's, right? And you might be making some more changes at the end of the day, right? But then, again, still the same old process is followed, consensus-driven, right? Where you have to come and everybody has to agree, okay? So it kind of shows, I mean, I talked about the numbering concepts, right? So you got, it's 21 requirements, 22 service aspects, and so on. And there are some variations here and there, but broadly, this is the kind of the nomenclature which they follow. Okay. Anyway, so I might be running out of time, so I'm going to go a little bit fast here. Just to kind of show you what people do, right? Like, let's say, for example, you're the inventor right at the center, right? And you have an idea, and you don't. I mean, there are repeaters out there which are, kind of archaic. It's kind of showing the dinosaur kind of repeater, and you have a new idea for a 5G millimeter wave repeater, right? So what do you do, right? And so you want to go and standardize it, right? So this is the idea, right? So in terms of, you get into the details in terms of what it's going to do and things like that. And the first thing you want to figure out is like, hey, which group is it relevant? Like, where am I going to submit this, right? And are there people already have something similar, right? Is the work already going on, right? Is my invention being already covered by someone else, right? And do I need to declare my IP? How do I figure all this out, right? So the first thing is like the 3GPP portal, you need to get an EOL account, right? I mean, you need to become a 3GPP member. That's like a prerequisite, obviously. With being a TSTSA member, we kind of help out with a lot of these things. So feel free to reach out to us. We'll be happy to help you. You open an account, and so here I go in, I open an account, and then I'm already logged in, and I go type in NR repeater, right? And then you can see looks like there's already somebody working on it. There's some relevant stuff already going on, right? So now you can go and figure out, okay, what is going on, right? Who's done it and things like that. So this gets into some more details on that, and so which all groups should I go in and submit my proposal, right? That's another place, right? So obviously you're working on the repeater, which means the physical layer. So RAN WG1 is a good place. There is a performance requirements involved. There could be other groups too. And a lot of times when you go submit it, you'll find out it kind of evolves. Architecture is another place. Again, depends on whether it's an active, you're obviously doing an active repeater here, right? So there's decoding involved. So anyway, so there you go. You go through all this process and then you finally submit it, and you could see that if you already have supporters and it's finally been agreed by people, so you could see the status, it says agreed, so which means that you're done, right? So there you go. Then you can go party. So that's all I have. I went through it quite fast. There's a lot of slides here, but hopefully you got a preview of 3GPP, but you guys probably already know a lot about this, so thank you.
Following on to the next topic, I would like to now invite Mr. Vijay Madan to give a brief overview of 1M2M. And before calling him up to the stage, I would like to read about his achievements. Mr. Vijay Madan is currently associated with TSTSI as advisor and mentor with special focus on standardization in services and solutions relating to evolving technologies and applications, vertical sector use cases, security and crypto, IoT, drone services, cloud computing, PPDR, future ICT, enabling systems. Also, JWG's focus connected with 1M2M, GPP ITUT. He is an election commission engineer with PG in business administration. Sir, over to you.
Thank you. Oh, I'm substituting for actually Arindam Bhattacharya of CDOT, who was supposed to be here, and he had an urgent meeting this morning. So he has gone back to Delhi. But it is almost a repetition of what we discussed yesterday. Suresh had discussed this as one of his presentations, and then what CDOT is doing or what others are doing. And so a sort of repeat. So I'll quickly glide through these slides. Next slide, please. So one or two things before I start my presentation are very important to appreciate and understand. That there are billions of devices now in IoT domain where they have to be connected, sensors, then gateways, and then communication systems, applications, use cases, incidents, and then they have to ultimately find their place in management where they can have control on IoT devices, and where can they get data from IoT devices, and how to manage that data, how to analyze that data, and all those things. So sometimes people are confused whether IoT 1M2M deals with communication part of it, whether it does with other parts of it. But when we see the advantages of IoT and structure of IoT 1M2M, and we'll appreciate what does it mean actually, and where it does it exist and lie. So actually, this is one of the best standards today, available standards today, and in progressively, it is becoming more and more open. It is one word of interoperable and security IC services, where market adoption is easy, delivers benefits to the society. This morning we were talking about monetization. Monetization of networks can be done if they are delivering services and all that. So as far as IoT is concerned, 1M2M has a vision, a mission that globally, when 3GPP gave us a mobile telephone, then interoperability was a necessity, because same interconnection with base stations, whether you are in USA, whether you are in India, whether you are in any region of the world, anywhere, it was necessary that standards are there, and our devices, UEs, follow the same interworking and interoperable systems so that you can go anywhere in the world. Now, this was a necessity because people wanted to be connected and people want to communicate. But if you see devices and IoT and all that, there are so many verticals. There are so many use cases where IoT is there. IoT can be just for a small company. IoT could be for a region. IoT could be for a vertical sector like healthcare and others, or IoT could be for any other societal use and so on and so forth. So IoT brings sensors, information through gateways and all that to a user or a controller or a data aggregator or an analyzer or vice versa and so on. So therefore, there are tremendous opportunities. People talked about today morning, yesterday also they were talking about monetization. So unless you have services useful for the community and for the verticals, simply laying networks will not help. So you have to reach out to various verticals. You have to reach out to various such sectors. You have to reach out to various implementation and deployments, and then get into the business of monetization of standards or monetization of innovation. Next slide, please. This is the organization part of 1M2M. You please come back. Please come back. So we have a steering committee, we have technical. This is almost having a basis as 3GPP has. It's a global interactive where many SDOs are there, and members of those SDOs contribute to the working and specifications and reports of 1M2M. So there are 3 working groups, SDS, PDE, and RDM. They work on specifications, they work on test methods, they work on innovations about usage and other things and all that. Next slide, please. So today, if you take, say, water management, if you take smart city management, if you take electricity management, if you say water, all other things have even a small, just one example, if there's a vending machine somewhere and it has consumables and consumables are to be refilled, there should be sensing device which has to send this information to the person who's a store person, and then some salesperson will come and replace these commercial items which can be used. So there are like that you can say there are millions of use cases for which IoT is used and all that. But everybody has got its own method, own organization, own workflow, and so on. Can we standardize this? That is the basic thing which 1M2M is handling. So smart transportation, smart infrastructure, smart energy services, all are vertical. And people have proprietary systems to do these verticals, from doing a job, sensing a job, and then reacting to that basically. So 1M2M breaks all these silos. Yesterday, one example was given of a car. Car is being serviced, is being provided by a retailer. Is it being serviced by a service provider? It is being managed, insured by somebody else and all that. So car has got 20 types of data to be shared and all that. If every person had his own method of doing, own work process, then you have millions and billions of these verticals and all that in this globe. So what 1M2M does is, next slide, next click, yeah. So all these verticals become horizontal. So service layer is a middle layer which has got 15-20 functions which performs authentication, data sharing, security, abstraction, and gateways to sending it to gateways and all that. So it is the middle layer between use cases, applications, and communication systems. And becomes, this service layer is agnostic, technology agnostic about type. It can connect to any communication system. It can connect to any service. So let that the communication systems do their communication job. It doesn't disturb them. Let verticals do their job in their own way. It doesn't distract them. But it acts as a middle layer to functionally flow the ecosystem and from end to end and all that. That is what one M2M does. It's a very, very, very significant issue, but people are using proprietary functions for smart city, for utilities, and therefore it's a mess. But billions of devices, billions of gateways, billions of transmission and millions of transmission systems, they have to be disciplined, regulated, and controlled by a standard system, which is service layer offered by one M2M. Next slide, please. So these are the 15, 20 functions as a common layer, common service layer, which is performed. For example, registration of the application, registration of the device, communication management, security management, discovery, then sort of things, you know, the telemetry systems send sensing to somewhere, and some control has to come, some control command has to come. So all these things happen with this service layer, and which is software intensive service layer, between and technology and application agnostic service layer, so that verticals are converted into one flow, horizontal workflow. Next slide. So release by release, one M2M has tried to make it an open system. The APIs between the system, between the network interfaces, between the application interfaces, it provides APIs, open APIs, where anything can be connected to anything. Any device can be connected to any device. Any sensor can be connected to main controller somewhere and all that. And release by release, more features have been added, more open source type of information has been prepared, so that in release 5, which they are working currently, becomes with so many possibilities that ultimately it is going to become as if you could plug and play with any device, you can plug and play with an application, securely transfer data to whom it is, to who's authorized to receive that data, who's authorized to insert that data. If you take the case of education, for example, the children are divided into poor children, these children, then you have midday meals for those children, you have next level of counseling for those children, you have their parents' information. So this will be used by many departments. But healthcare department, medical department should get only healthcare data out of that. So that abstraction is unique to the people or to the authorized person who's to use that data. And this data may be shared across, inserted and shared. Next slide, please. So this is the release 5. Now we are at freezing of release 2. It has been ratified, and we are going to transpose release 5, all the members of this one M2M. And release 4, and release 5 is expected to be there in quarter 25, second quarter 25. So this provides the time frame. We have technically plenary meetings, we have working group meetings, we have steering committee meetings, and ultimately everybody pulls together to have one common workflow of IoT, whether it is industrial IoT, whether it is human IoT, whether it is IIoT, whether it is ambient IoT. There are various formats of IoT, IIoT, and so on, which have to be done by that. So we expect, and TSDSI members are extensively contributing to one M2M. Over 500 contributions have gone from India. And unlike other 3GPP and other things and all that, one M2M is one organization where TSD is just behind HC. So we are second in the globe, giving contributions, using contributions, and having leadership position in one M2M. Next slide, please. So TSDSI engagement in 1M2M is to support standardization of IoT M2M domain, and they are providing. So it is emerging, it is evolving. It's not like 3GPP 6 release 18 or 19, where it has enough matured for last so many years. It is a niche type of work which started a few years back, and therefore it is still evolving. So what we want to do is, we have so far given free membership to all our IMs. Every membership costs $300, $3,000 or $4,000. Every member has to pay. So we are not charging any fee at the moment. So in turn, we are participating as a secretariat of 1M2M and providing our manpower to manage the working groups, to manage the steering committee, to manage the Marcom and other activities of 1M2M, so that we work, so much work we do. If 58 members into $3,000 worth of work we are doing for 1M2M. So it is providing an in-kind support to 1M2M secretariat in place of what you call as if we had to pay cash or something like that. And we have already transposed Release 2 and Release 6 standards, which have been adopted as national standards for smart city and other verticals. In fact, BIS has gone a step ahead. They have adopted these standards as normative references for smart city architecture and all that, for state commissioners of IoT, smart cities and smart verticals and all that. TSG members are actively participating in SDS and TDE working groups. TSC members have submitted over 5,500 agreed contributions till date. Maybe there are 5,000 or like that. So at least 10-15% contributions have gone from TSDSI. From CDOT, they have received Technical Excellence Award there as an IM. TSDSI has secured 4 leadership positions in 1M2M as steering committee, Marcom, SDS, WGs, and other things. Next slide, please. Like some examples, CDAX, Cosmic, which is Common Smart IoT Connectivity, a membership platform for data sharing with field devices and application different verticals. Smart City Sitting Lab, one based on 1M2M, has been set up by IIIT Hyderabad in their campus with the data exchange in between. CSP or CDOT Common Service Platform has been developed, and many hundreds of people, startups have signed up with CDOT to do various things. And the beginning part of this is slightly old. Smart city use cases with Bharat Electronics was done. Also working for Indian Railways for 1M2M based deployment, source deployment experience in India presented to 1M2M industry use case in meeting in Tokyo also. It was presented, well appreciated. We are just following Korea at the moment, who are leading in 1M2M IoT deployments and all that. TSDSI have organized many 1M2M webinars, hackathons, tutorials, workshop in India, and some in collaboration with European Union also. TSDSI successfully hosted 3 well-attended technical plenaries in India, like we did for 3GPP, TP858, TP42, and TP31 between 2019 to 2023. And now we are going to create one more in Delhi, perhaps, sometime next year in 25. And we are having some hackathon, other events also, along with the hosting and all that. Then one part of the hosting is very important, is Industry Day. In every technical plenary India has hosted, we have had midweek as an Industry Day. We call all verticals to play with that platform, see whether they're compatible with 1M2M application platform and all that, functional software, functional platform, workflow, etc. And progressively, perhaps, because it's a national standard, government may decide that for some critical sectors, this may be mandatory to have this as a standard. Otherwise, it's a voluntary one. Next slide, please. So TSDs have organized webinars, hackathons, and successfully hosted. This I have mentioned in the previous slide. So that was total present. Next slide, please. And thank you very much for this.
We'll move to the Q&A session for this segment at the last after the end of all the speakers. And we are moving to the next part. So at this moment, I would like to invite Mr. Jishnu Aravindakshan to give a brief overview of ITUR. Talking about Jishnu, sir, he is a principal architect in CTO's office, Tejas Networks India Limited, where he is responsible for deciding the long-term roadmap of the company. He obtained his BTech in Electronics and Communication from NIT Calicut in 2001 and Masters from IISc Bangalore in 2004. Subsequently, he joined Tejas Networks and is responsible for deciding the long-term roadmap of the company. He has requested Tejas at ITUT SG15 and has contributed towards the development of ITUT G.8032 and MPLS TP standards. Over to you, sir.
So let me start on what actually happens with each generation of phones which you carry. So each generation is roughly 10 years. So the standardization cycle actually starts with ITU putting together what is called a vision document or a framework document. Like the 5G just got rolled out, the next version of the standardization work has already started. So any person who is working on research, etc., especially on those set of development, this is the right platform to get into something which is like evolving. It will evolve over next 5-6 years and eventually come to a product around 2030. In 2030, hopefully all of us would be carrying a 6G phone, which would be exactly same as the specification, which if you are contributing would be what you had contributed into the standard. So how it starts is, it all starts as a first document which comes out is called a vision. It's recently renamed as a framework document. So you can go and search what is called ITUR M.2160. So this is basically taken, the picture is taken from there. It's a readable document. You can just go it. So it's not like very complicated with mathematics or something. So just go through it. So it starts with figuring out what are the use cases which 5G cannot sort out. So what are those requirements which 5G never addressed? So that's how it starts off. And this input come from multiple companies, countries, and all that. And finally, a consensus is formed on figuring out what are the basic set of what's called the usage scenario. Each usage scenario will be able to address multiple use cases. So the first step in developing any generation of standard is actually to come out with what is called the usage scenarios. And to meet those usage scenarios, you would need additional set of what is called the capabilities in the ITU terminology, or it's called KPIs in the 3GPP terminology. So once this comes up, you have multiple set of problems which comes up, which is like in ITU itself, there are slowly you can see many things have converged. So in 2G, you had multiple technologies. There was it started with GSM, and there was also a 3GPP2, which were WCDMA and all that. So multiple technologies were there. If you see now in 5G, there are only a single one, and then there was the other one which came from TSDSI, which was called the 5GI. But both were relatively similar. The 5GI was slightly improvement over 3GPP. So to start off, what happens is you come out with set of usage scenarios, which actually takes out use cases, club it into a usage scenario. And for each usage scenario, there are capabilities which has to be met. Say, for example, when you say hyper reliable low latency communication, what should be the latency level? Which should be there is a point of discussion. So, for example, the latency here is on the radio link. So it was supposed to be a millisecond in case of 5G. We are supposed to go down further in 6G. What reliability? The earlier reliabilities was around 5 nines. We are now trying to get more than that. How do you go and propose something, a number? So you can see here in the green circle, there are some numbers already mentioned. So some of them already, there is a research output which are available. For things which are not there, usually more research has to come in. And then it actually gets standardized, or that KPI gets assigned what is called a test environment and an evaluation methodology for each of those usage scenario. So in 6G, what has happened is the usage scenario you can see is like you have, in addition to the three of them, which was in case of 5G, there was EMBB. So if you see enhanced mobile broadband, so all your phones, if you have a 5G phone, are mostly capable to support EMBB. This feature actually got completed in release 15 and 16 of 3GPP. So once those requirements came in from ITU for what defines an EMBB usage scenario, appropriately the standard development organization, including TSI, 3GPP, starts working on giving a particular solution to this. So the original problem that is defined by ITU, which gives you a broad requirement set of thing, along with what are the spectrums you can use. So spectrum is completely dealt in ITU because it has to be globally harmonized. The first question is, why are we doing all this, right? Why should I even ITU come in? So ITU is a treaty-based organization like what we see in UN and all that. So as soon as some spectrum get assigned for a particular function. So for example, what we do with our phones today is called IMT. It is it's basically you connect to a terrestrial base station. So you don't connect to a satellite phone. Why is that? Because those spectrums are completely different spectrums. So satellite spectrums are usually in the Ku, Ka band. So those spectrums are assigned for that purpose in ITU. So the spectrum assignment also has to happen side by side when you develop the technology. So there are discussions happening on spectrum. Spectrum around 6 to 24 gigahertz is being discussed for 6G, and then higher frequencies in sub-terahertz, 100 to 300 gigahertz are being discussed. So the frequency discussion happens in ITU, along with what should be the broad requirement, which are not covered by 5G. So in the case of first usage scenario, EMBB has been evolved to what is called an immersive communication. So 5G already has done some basic work on XR. Say for example, you might have heard of Vision Pro. Sadly, they never added 5G into it. So it's right now only with Wi-Fi. So hopefully in the next generation, like what you have seen in Matrix movie, maybe you will get a glass which can be used in outdoor scenario. Right now, whatever XR, VR headsets are there, it's always in an indoor scenario. You can't walk around because there are issues on how do you structure that inside it. So maybe the next generation, at least a proper XR, usable XR on an outdoor scenario would be coming up. So the XR problem, if you see right now, is like if you have to do immersive communication, you would have a handset. You don't know whether I can make it a much larger thing. So you will have a limitation on how much memory, processor, compute, etc., which you can put on those XR devices. So there are some effort right now being discussed, so that will eventually converge in 6G. It's like how much of those compute processing would come on your XR device and what should be done on the edge part of the device. So those aspects are something which gets decided. So if you have a high throughput, lot more of those things can be done remotely at the edge. But if your throughput are lesser, you would have to do a lot more, all the latency sensitive stuff on the device itself. So this would be one change. You could put a lot more of your processing compute onto the central place if you have a larger capacity between the device and the network. So the effort is right now you are in 5G, it is supposed to be peak throughput is 20 Gbps. And the issue was, see what has happened is if you can see here, it's clearly mentioned that this is for research and this is for not for deployment. But this diagrams become so popular that people expect similar numbers to come in. So that's one reason in 6G that numbers were not put, the actual numbers were not put. But in 5G, the EMBB number was that the KPI which you were supposed to meet was around 20 Gbps peak throughput. So 20 Gbps peak throughput you would have got for a certain set of spectrum and a certain bandwidth. So that was the reason you will not get it on your phone today. So if you run today, you don't get a peak throughput of 20 Gbps. This is supposed to be on millimeter wave. So all those nitty-gritty get lost when you put such a diagram. So spectrum determines, so if you see in communication right now, the only way to scale the thing is that you increase the number of antennas, which you are more or less on the Shannon edge on the other thing. We don't know what AML can do, so that's another thing which is not known. There are a lot of research happening on the receiver, and we move it to AML. So that's one part of those research. So that's one other thing which is being looked up. Can you have AA and communication coming together? So whether that receiver, sorry. So that's the second thing. The URLLC never really took up because it was mostly done in the later stage of 3GPP development. So the initial thing didn't do much on reducing the latency. So the initial concepts came in, like you could have a smaller slot, you could, if you increase your subcarrier spacing, you could have reduced the latency. But the initial deployments all happened with 15 kilohertz subcarrier spacing, and in 3.5 we are going to 30 kilohertz subcarrier spacing. So that should reduce the latency at the radio layer. But from a user perspective, that saving not seen because you see mostly an end-to-end latency, which hardly has any impact because of those few millisecond saving which you do on the radio layer. So we want significant improvement here. So if you really have to use XR in a proper way, you need to improve latency, and you have to have edge coming in the sense many of your base stations should have computing and processing capability, which is not there today. It's mostly compute and processing which we have today in this is basically for the control plane purpose, etc., but not for a user plane purpose. So once you bring that part near it, and if you can reduce the latency, so that would be one real improvement. So we will see a new architecture can come in as part of this for reliable low latency communication. Sensing and communication is another which is coming up. Sensing was never done in 5G, so this is completely new in that sense. So what is sensing and why is so? All of you have a phone. So phone can give you inside this room. Maybe the GPS may not be there. So you have in 5G a capability to detect you based on triangulating based on 2-3 base station to which you might be connected to. So those schemes which came up, and because in 5G there is also this concept of angle of arrival because you are working with beams, you can actually detect in 3 dimension where you are standing if you have a phone and you are holding that phone. But what happens for all the chairs which are not where there are no one sitting here? Can I sense that? So if I am able to sense that, maybe in a holographic image, I can place a new person to sit next to another person, but he's not where the seat is vacant. So if you have to create what is called a holographic presence of this room, I think there are more people online than physically in this room. Can I get all of those people holographically on all the remaining seats so that at least you feel that hall is full or something like that, and people can interact. It can be more interactive. So such thing would need sensing, and for sensing you would have to figure out what exactly do you mean by that. In the sense, you are using frequencies which are in the radar range. So it's more like the frequencies which you are talking about. 6G has some radar frequencies and even higher terahertz frequencies, sub-terahertz frequencies. Can you use it to do a lot more of sensing? Because you have now a lot of bandwidth. You may not have that much of data to send. Can I use the remaining period of time to sense things which are not actually connected, in the sense they don't have a SIM, so I have no way to connect. There is not even a MMTC type device, so it's basically an object which we have to sense. So this is a completely new topic which has come up. So this is an area where you have to start from the very basic. So what work is happening right now is how do you do the channel modeling for this? So that's one work which is sort of started in 3GPP. The other aspect is you might have seen FASTag. It mostly works on RFID. So that basically sends a signal. There is no battery on those RFID tags. So it basically has a sort of a capacitor which gets charged, and then it's sends back those information back. So these are devices which are in 3GPP term called ambient IoT. In ITU also it's defined. So it's called, it basically should not have a battery type thing. This device, it's called device 1 in 3GPP term. So can those devices be also brought in as a new usage scenario, which was not something which we which right now was using unlicensed band, can it also move into a licensed band? One advantage of licensed band with respect to as soon as it becomes an ITU band, etc., is that you can put lot more power and you have control on who is putting power on those spectrum, because it's like the spectrum are allocated through auction, and there is no chance of it getting degraded over time. Like what happened with in Bangalore, every one of us know there was a company called Ticona, which started as a pure Wi-Fi operator, but it was initially very good, was able to give quite good capacity. But over time it degraded because people even at home, we also started using our own Wi-Fi. So unlicensed band, beyond certain point, it doesn't work. So the same issue may soon happen with many of those RFID type applications. So the other thing which you can see today, I don't know whether you have gone to one of those Geo stores. They give you a VR set and you can actually go and pick up some object from a Hamley store in Bombay. So there you can see the RFID tag, and if you want to sort of read that up, right now there is no way. It's RFID is RFID, and you can't. So they are inserting it as physically as a separate thing into it. This can also be live read in future if you are integrating that hologram into it. So this is a new category of devices which are supposed to come up. This is another topic which is there, but that's not shown in the usage scenario, but it's mentioned as part of one of those usage scenarios. Coming to the capabilities, there are 15 of them. I think 9 of them were already defined in case of 5G, which are shown in green. The things on blue are something which came as a new set of capabilities, which are, some of them are quantifiable, some of them are not quantifiable. So you can see, ideally everything should be quantifiable. So we'll see how it gets evolved. So interoperability right now is not a quantifiable metric, so it's not well defined. But things like reliability is well defined, latency is defined. So you can see right now they have given a range, 0.1 to 1 millisecond is the target which we are working out. So it's roughly that we want to see whether we can reduce the latency by a factor of 10. Reliability by, you can see those numbers there. Mobility, so right now the maximum we can do for phones is that you can use it on one of those trains which run in Japan at 500 km/h. But the speeds are 1000 km/h and you can't use your phone. So you would have to, right now, if you get into any plane, you basically connect over Wi-Fi, and the other one uses some satellite technology to connect to the thing, which is actually, you don't get the only place you don't right now as in terrestrial area, you don't get broadband speed is in plane. So that's one domain which is not targeted till now by 5G. Hopefully 6G can handle it, because we are trying to see whether you can scale it up beyond 500 km/h. Some numbers have been put. The other numbers would get discussed in what is called the next phase of this part, which is called the requirement phase of speed, because it's basically for your smart meters. So you may not need a lot of your user speed, but you may need to connect a lot of them. Say, for example, if I want to monitor a temperature of the country at almost every location, and we are just throwing away some of those sensors everywhere and just trying to measure those temperature out of it, then the base station will have to connect. Right now, if you see, roughly 2000 users connect to a base station. But here in this case, if you have a lot of those sensors, you'll have 10 times more or even 100 times more users connecting to the base station. But I don't need to continuously connect. So I can do something efficiently whereby I connect to him once in a month, collect the data and all that stuff. So each usage scenario may have certain bunch of KPIs which are relevant. Not all KPIs or the capabilities are relevant for each usage scenario. So that's why this part on how to map capabilities with usage scenario and how to evaluate it. So when you say evaluation here, we don't actually make a product and evaluate it. What is done is you usually do it through simulation tools. So mostly some companies have their own in-house simulation tools, or you use MATLAB, which all of you might be already using it. And you do what is called a link level simulation for scenarios where you have to check the path laws, related stuff and all that. or you do a system level simulation to see what happens if you have multiple base station, if you have to figure out the interference, etc. So these are the two basic studies which would happen. Some of these are purely analytical in the sense you can like link budget, you can calculate with your pen and paper. So all those different categories of checking whether a particular capability meets the KPI is done in this second phase, which is called the requirement phase. So that is what starts off. Once those requirements get finalized, the opportunity is given to all the SDOs. TSDSI is also one of those SDO. 3GPP is an SDO. They can come out with a standard which can meet all those KPIs and those usage, whatever is the test environment. If those stuff are met, that is adopted as an IMT technology, because this is what we are discussing here is ITU or WP5D. But if it can meet some other things, satellite is done in a different body called WP4C. So if they meet those capabilities, that is adopted by ITU as an international standard. Once that becomes an international standard, it allows each one of us, if you have a phone, to basically move around, and if people implement those particular standards, you would be able to connect to any network anywhere in the world, provided you use those spectrum and use those same technology. So ITU gives those the capability to adopt a particular standard. So right now the 5G and 5GI was two of them. 5GI actually got wound down into release 17 of 3GPP. So effectively there is one standard. So if you have a 5G phone and if you are in the same band, you can connect any network anywhere in the world and still be able to talk. This is one difference which you will see from ITUR versus other ITU bodies. So for example, in an optical communication, I don't know how many of you are in wireless, how many people are working in wireless? Okay. How about others? What are they working on? Which field? Just one of you. Is it optical or something, or anyone on wireline? Anyone on AML? Okay. Okay. So basically, yeah. So based on the topic, you could pick up on a particular topic and then see whether if you want to give numbers, the KPI numbers. That's what right now the work is happening. So here, at least in ITU, it works usually as a like we present mostly as a country, not as a individual or not as an individual company. You can give those input. TSDSA is also a sector member. You can provide input as TSDSA, but the impact is much more if you provide that input as a country. So usually India have Indian delegations which you attend it, which gives input as a country. And if there are issues, usually the countries discuss among each other and provide a consensus. Here it is unlike 3GPP, it has to be consensus. There is no much option for voting. Voting is only to basically kill the complete project, which usually doesn't happen. So the countries come together and sort of reach a consensus in the aspect. So if you see in the earlier slide, this is slightly older, the word integrated was dropped. Integrated AAN communication means the same base station should be able to do AAN communication. Right now, the word integrated was dropped because Iran had some issue with that. It looks like Iran is okay to have AA on the hands, but not on the base station. So such nitty-gritties get lost in the sense if you read those documents, the final words, each alphabet is actually verified before it goes there. So, and it's verified by all the countries. So usually the countries have a much bigger role here. And if any one of you are interested, maybe reach out to TSDSI and DOT. You can become part of the India team which goes and contribute. And each of us can work on a particular topic and then sort of get the initial requirement fine. And beyond that, you can work in 3GPP and TSDSI to actually come out with solution for this problem. So right now it's about problem definition in 6C. So with this, I am done. I have only 2 slides. Any questions? Okay, thank you.
Thank you, sir. I would like to now invite Mr. Vishnu Ram to give a brief overview of ITU team. Talking about Vishnu, sir, he is consultant TSDSI has hands-on experience in the field of telecom industry for more than 20 years, developing and implementing standards, and holds many international granted patents. He is a senior member of IEEE and active member of uh, NWG 13 in India and vice chair of ITUT focus group on autonomous networks and co-convener of ITUT correspondence group on datasets. Over to you, sir.
Vishnu, I will go through the ITUT portion. I think most of you may be already familiar with ITUT. Just to give you a brief introduction, ITU is basically a UN specialized agency, like Jishnu just now mentioned. But this is the telecom part of it. So you will see mostly applications, services, use cases, future networks, architectures, and the AI, machine learning, such concepts being discussed there. Radio portion Jishnu already covered the radio portion. So my approach today, I will look at mainly practical opportunities where you can engage with ITUT. That is my intention today. So there are 4 opportunities that I will talk to you about. First one is how do you start contributing to ITUT? What are the building blocks of this kind of standardization pipeline, if you will? And the second one is in Delhi we are having WTSA and other events. TSDSI is a sector member of ITU. So you can engage with us, along with us. You can be part of this WTSA World Telecom Standards Assembly in October of this year. So that's the second opportunity. The third one, I will talk about open data sets, which is being made available as part of ITU AI for Good. And finally, I will also talk about how to take some leadership opportunities for taking the contributions forward. Okay, so very quickly, if you look at how do you build this standards pipeline? So there are 4 steps here. First step is that you look at how to build the pre-standard activities. So these are research studies, academic industry, pre-standard research. You may engage with ITU focus groups, that is the pre-standard body in ITUT, as well as there are standards groups which are, of course, study groups which are standards activity. There is WTSA resolutions which study the nature of the work which is being done in ITU. There are informational documents such as supplements, we call as supplements. And then there are, of course, TSDSI documents which feed into any of these activities. So that is the initial entry point is this pre-standard activities. Step 2 would be you derive requirements which comes as part of this pre-standard activities. Review it with supporters, basically form a team, form an ecosystem which can support you with this kind of standards contributions. Then you need to have some unique value in this. So you may have an IP, you may have a regional viewpoint, some form of customization which will help you differentiate from others. That is the unique value which is based on fine tuning for maybe specific use cases or products that your company has, or some research value which you are bringing to the contribution. And then the final part would be to create some supporting material with results which may be built through open source or not, but basically justifying your choice of architectures and requirements in your contributions. So overall workflow is that you do your ITUT contributions based on pre-standard research. This is a very good example. What you see here is a very good example. Okay, so this is a architecture framework for autonomous networks. This is a standard document. You can see this is an ITUT document. And this numbering will show you which study group it is coming from. Y dot series typically come from study group 13, which is related to future networks and so on. The numbering, the 3061 is a unique number for the standard. You look at current status of the work is that this recommendation is published. The prototype implementations with global collaborators, that is post standard activity that is currently going on, and the research on developing each of these interface specifications, which you see here, these numbered interface specifications, that activity is currently going on. So if you look at each of these rectangles, they show what kind of subsystems are in this architecture. So on the build up to build this standardization framework, as I explained previously, each of these rectangles that you see here as subsystems were worked upon, contributions were built based on this, and then finally distilled into this kind of an architecture framework. So you may ask what are the main aspects which are currently going on. So there are four main items which are currently going on. First one is building of this knowledge base content. This is for the knowledge base subsystem. Intent based driving of this orchestrator over here. So that's another role of intent is being studied. Experimentation and validation subsystem. So that's for AIMS sandbox for experimentation. That's currently going on. And specific use cases is for regional operators. So for example, from India or from Europe or from America. So this kind of regional operator case studies for specific use cases is also studied here. The second opportunity that I promised is about World Telecom Standard Assembly. This is going to happen in New Delhi in 2024. This is a global assembly is a high-level decision-making body of ITU. This is held every 4 years. Last time this was held in Geneva because of COVID and other problems 4 years back, and we were delayed by 2 years because of COVID. So basically, this is coming up in October 2024 in New Delhi. The main aim is to set the direction and structure for standards development. So you can see that this will be a high-level forum, and this is where you have to be if you want to influence the standards making process, the different study groups, focus groups, and so on. If you would like to influence that, this is the place to be. TSDSI actually held a awareness workshop, and you can see the details of the awareness workshops here. 14th to 24th October is the dates. Please mark your calendar. As sector member of ITU, you can register as TSDSI delegate. You can go to our website or contact one of us to register and contribute as a TSDSI delegate for WTSI. As part of this, in October, we are also having a bunch of publication opportunities. So first is this journal, which I will talk about. That the ITU journal is for future and evolving technologies. This is a pre-standard research activity that I talked to you about. So if you have ideas, papers, publications, then this is a good opportunity. By the way, we have had Samsung and other teams from India, including Nokia colleagues, publishing IIT Delhi and a couple of other institutes which have already published papers in this. This is a paper on AI-based indoor localization, positioning and localization using millimeter wave MIMO. This is from our team in Samsung R&D Institute right here in Bengaluru. We also had people joining us for these webinar sessions in ITU AI for Good also. Another opportunity is for this Kaleidoscope. Kaleidoscope is actually an academic conference. This happens every year. ITU Kaleidoscope this time is happening on the sidelines of WTSA. This is again in Delhi. The dates are slightly within the time frame 21 and 23rd, 21 to 23rd October. If you remember the WTSA complete group and meeting announcement groups, you can join through WhatsApp if you like. The first prize is 6,000 Swiss francs if you go to and win this kaleidoscope paper presentations. In addition, you can take the stage and present on during this WTSA. Young authors less than 30 years of age stand a chance to win the Young Authors Prize if your paper is accepted. You can of course network with peers and so on. The next opportunity that we have is for open data sets as standards enablers. ITU actually publishes data sets. These are completely open to anybody. It's not every day that you get data sets from the network, real data sets from operators published from the field, collected and published from the field. So many of these are actually, this one is from 100 base stations in a particular country, and it's from a real operator published via Huawei, but it is from a real operator. This one is a Barcelona neural networks. This is on graph neural networking, and this is a startup based out of Turkey, and this one is Berlin V2X data sets from AI for Mobile Consortium in Europe. So there is a bunch of information that we metadata here, for example, base station data information, cell level data information, energy consumption data. These are all 8 days, more than 1,000 RRUs published from different vendors' products. We had some success from India's side. Again, Samsung Research Institute have been pioneers. We had people from other organizations. Nokia colleagues have won prizes. I know that they have published also. Currently ongoing, we have actually some prizes here. $15,000. Who wants $15,000? So, so here you can see is a metaverse challenge from ITU. This is on IoT, tiny and smart stations. So these are all possibilities of analysis and utilizing these open data sets to come up with papers and then develop it towards contributions. This one is on large language models. This is a very unique challenge because it uses RAG for public service and administration tasks, and this is fully locally offline development of large language models. So if there are public sector institutions which would like to install and test in their personal devices, that's why this comes in the form of 7B models, Llama 2 7B models. This one is a challenge from a collaboration with IEEE and a bunch of other bodies. This is open data set as standard enablers. So this is quite interesting because a bunch of 3GPP documents are parsed and made as Q&A data set. So I saw that one of them is a release 17 document, but it's pretty interesting that they have made curated this data set. This one is up in our website. You can see this in our website on ITU. So this is a unique place where you see both standards, domain knowledge coming together as analysis in the form of data sets, both in the Falcon model and as a 5.2 model. Global leadership, so you study such use cases, whatever we showed just now, and pool this knowledge base from around the world. For example, this is just an example flow. You look at advances, create knowledge base, and look at the pre-standard activity. Engage with us on AI native features in 6G and such advanced topics with architecture frameworks and gaps analysis. You heard the experts today morning talk about AI native. I think Nirant talked about it, and I think Mohan Rao talked about it as well on AI native features. So here is an opportunity to take these contributions to ITU again in the form of use cases and standards. For example, Tata Elxsi is we have been working with them very closely. They are actually presenting this use case in ITU workshop on 30th May. Their use case is selected. We have had weekly meetings with them to go take this forward. They stand to win a prize of $80,000 US dollars totally put together. So I think this kind of opportunities brings you closer to analysis, closer to maturity, closer to building your contributions together for different focus groups and study groups. And this is how you look at the 4-step process that I showed you in the beginning. That is pre-standards going to all the way to creating proof of concept. I have heard, when I talk to colleagues, especially institutes and industry, I hear excuses. I hear many myths saying that there is no data available, that there is no support available. We don't know where to go. But these are the places where you go. There is open data, there is support available, and there are success stories. That's the message which we would like to pass today. And we are here. We have mentoring, hand-holding from TSTSI for ITUT contributions, and you can talk to me anytime. Thank you so much, and let's talk the questions. I'm around or at the end. Thank you.
Thank you, sir. I would like to now invite Mr. Subhash Mondal to give a brief overview of IEEE SA. Talking about Subhash Mondal, sir, he leads the R&D efforts for the 5G product development at HFCL as a Senior Vice President. In this role, Subhash works with academia, standards development organizations, and technology partners. The portfolio of products include ORAN-based macro RU, indoor small cell, medium-range outdoor small cell, and transport products for interconnecting disaggregated RAN nodes. Subhash holds an engineering degree from IIT Kharagpur in electronics and electrical communication engineering. Over to you, sir.
I don't have a slide. So good afternoon, and I hope I will be fairly quick. So just before I start, I thought I will do a little bit of an interaction. How many of you are IEEE members? If you can raise your hand. Okay, not many, nothing to worry about that. How many of you are IEEE Standard Association members? If you can raise, I can see only one hand going up. So then the question comes, how is IEEE relevant in the context of 6G? That is the primary focus, I guess we are talking about 5G, beyond 5G and 6G. So what is your view? Is IEEE relevant in the context of 6G? What's your reaction? Anybody? Relevant, not relevant? Yeah, please go ahead. Okay, so you talked about IMT Advanced, they tried a specification, but they dropped the ball somewhere in between, right? Okay, so let's set the context right. Where does the IEEE technology fit in the context of 6G? So as you know, ITU, a lot of talk has happened about the ITU framework for IMTs, IMT 2020, that was 5G, IMT 2030, that is 6G. It talks about a set of use cases that involve indoor and outdoor use cases. IEEE, if you look into the way it it evolved. In the context of cellular specification, IEEE has a broad set of specification cutting across the entire technology landscape, and IEEE is more known as a research and conference organization, lesser known for IEEE Standard Association, which by the way was one of the oldest. But in the context of cellular wireless communication, which IMT defines, where does really IEEE technology fit in? So it really fits into the indoor, local area, metropolitan area use case scenarios. So if you really look into the 5G time frame, IEEE made a bold attempt that we also would contend for compliance to IMT 2020. And then it realized that we probably will do best. We will exceed the requirement of indoor use cases. But if we have to do a outdoor use case scenario, so you know that cellular wireless, there are 3 power classes. One is called the local area, medium range, and wide area base stations. And if you have to cater to that use cases, it's a huge heavy lifting. And the IEEE is known for unlicensed technology, whereas 3GPP is known for licensed technology. So the real agreement was that do we really make that extra effort to go beyond and spend effort where we do not have the core competency? So the kind of decision was made, let us focus on where we thrive in terms of unlicensed technology, and then when it comes to NR unlicensed, which is what got developed in 3GPP, it was a collaboration between IEEE and 3GPP. So it makes life simple. So now then the question is, how does it really fit into the 6G time frame and the technology evolution? So if you really look at current generation of IEEE unlicensed radio technologies, Wi-Fi 6 is pretty much done. Wi-Fi 7 is something that is already, I would say that products are in the market, the final specs are on its way. So Wi-Fi 6 delivered pretty much about 10 Gbps throughput. In the indoor hotspot use cases, that is the sweet spot for IEEE. And Wi-Fi 7, that is expected to deliver 30 Gbps. And the next Wi-Fi 8, which is still not started, it is going to extend it further. You know that many countries, including US, have made the 6 gigahertz spectrum band available. And Wi-Fi 7 has brought a set of new features called channel bonding, preamble puncturing, and things like that to enhance the capability of managing the interference better in an unlicensed scenario. So this, when it is extended further with the wider channel bandwidth through the channel bonding and all, a lot of potentials open up, and most of the indoor use cases may not require a bandwidth beyond that. So there also are efforts underway in terms of ultra reliable communications, something that happened into URLLC equivalent scenarios. So that also would be very, very relevant. And on the terahertz, you may be already aware that IEEE has gone the higher millimeter wave band for a long, long time, 802.11 AY AD, operating at 60 gigahertz band that has been around for a long time, though it was not commercial success, but technology exists. Now the question, one of the part was that how do we really contribute and make it relevant from the India context? So you may be aware that there has been some amount of contribution that has happened from India in IEEE. And for you, if you are not aware of, IEEE has 2 kinds of contribution. It is not necessary that you are a member of IEEE SA for you to be contributing. It is not even necessary for you to be a member of IEEE. So many of you who are not member, you still can contribute. If you think that your research that can translate it to a standard technology, you can contribute as well. However, there are 2 types of contribution in IEEE. It all starts with what is called the PAR, which is Project Authorization Request. And if that gets approved by the standard committee, then you can take it up. And there are two categories of specification that you can have. One is called the individual, which does not require you membership, you can contribute as an individual. And the second is called the entity. So the entity process has its complicated mechanisms that you have to be an organizational member and anybody from the organization can contribute, and the voting rights will be vesting with on an entity basis. So it gets fairly involved and complicated unless you have a lot of deep investment into this. Sailing through that consensus process is complicated. Whereas in the individual basis, every individual contributor into this specification can vote, right? So that is essentially the difference. And for your information, 802.11, which is the flagship specification of IEEE in the context of the wireless communication, it was an entity driven specification for a very, very long time, but now it is individual, which means that you as an individual also can contribute into this, right? So if you have a research proposition, you have created assets in the form of a publication or patent, and you now would like to standardize it, opportunity exists. You can propose it as a pair, as an individual specification, and it will get accepted, right? Provided there is a merit in your proposal. So it is fairly straightforward really, and there are few notable contributions that has happened. Frugal 5G was one of that. That was developed by IIT Bombay and IIT Kanpur together. Pranab Jha has been leading that. There also has been interoperable and secure wireless LAN. This was developed by Sandeep was the chair from CDOT. He has been part of the PM-ONI program. This is P2872. And there also is a rural broadband, P1941.1. So these are some of the notable contributions from India. And if you would like to contribute, it is fairly straightforward. IEEE, yes, I think Sandeep is here, right? So I didn't realize in the low light, it was Sandeep was there. So it is fairly straightforward. Sandeep is here. You can reach out to him. He is an expert into this area. He can guide you any way you would like. So with that, I'll conclude. If you have any question, I am around tea time or otherwise you can connect. Thank you.
He leads the RAN innovation team at Sankhya Labs, which is now Tejas Networks, which focuses on creating value in terms of product and service differentiation in the next generation wireless infrastructure. He has over 2 decades of experience in developing software for wireless systems ranging from GSM to 5G NR. Over to you, sir.
I think it's always difficult for the last person speaking. Okay, so I think we have seen many startups and organizations and how they are structured and what goes from one to other. Like starts with ITU, probably goes into 3GPP. Then you have the member bodies, TSDSI, etc., who work on that. Then why do we need one more? Standardization body? I'm talking about the ORAN stuff, which I'm going to talk about here. And let's try to see or drive the motivation, why need for one more and how it came into existence and what it focuses on. Then we'll probably talk about the work groups, etc. It's more quite flat as compared to any of the other standard SDOs. So ORAN is Open RAN is more like a concept that okay, we need to have components interoperable, you can take from many vendors. And this was more of an attempt to split the RAN market. So was the cellular system not open? Yeah, it was open. The UU interface is standardized. The cell phones interop with anyone's base station, the core networks, or the base station interop with any of the core networks. And why do we need one more thing, right? So there was a project which was started by the telecom infra project called the Open RAN. So this was more of a project and not a concept. And then the idea was, okay, how can I bring in various components and build the RAN part? And simultaneously, there was more and more of traction towards the cloud architectures and virtualizing the components or the network elements which form this RAN. And then there was something going on, what was called virtual RAN or vRAN, right? There were many organizations which were active in this space too. And within this, there was an organization, or not an, it's an organization called CRAN, which was more of European operator centric, which was working on cloud native principles to build a RAN. So along with CRAN, there was another China and East Asian body also called XRAN, which was working at the same time, right? And then what it focused on, while the CRAN was more on cloud native parts, XRAN was more on open interface, and you see this interaction of the open RAN and the vRAN. That's where you fit the XRAN. And eventually, at one point of time, we said that okay, that these two organizations merged, and what we have today is the ORAN Alliance. And it's good to differentiate, right? There's a difference between ORAN and Open RAN, where one is a concept, the other is the SDO, which churns out standards for you to implement. And this is worth noting because there's a lot of times the confusion in what Open RAN in and what ORAN is. So, what were the objectives for this SDU? It was the main one was cloudification and virtualization, mainly for dynamic resource sharing, and then you have COTS hardware in place instead of purpose-built systems, ASICs and FPGAs, on which most of our earlier base stations and select systems were built. The second part was more of disaggregation. This was more to break monopolies. So you can have RU from one vendor, maybe a CU from one vendor. We'll see what its terms are, and this was done not just to improve or what do you say, pricing structures or break monopolies, but more it was required also because things scaled in a different way. So the users plane scaled more with traffic, the control planes scaled with users, and it was wise to split it in that way. And then by doing this, there are more and more small players can come with their own contributions and try to be part of the bigger mobile network ecosystem. And at the same time, if we have to do all this, we needed disaggregation. Otherwise, the interworking is a big mess. If you bring a component from one and the other one from other, and both of them have to work together. And of course, then when you have different components, you need some sort of common management and orchestration system. So something like SON or the EMSs and NMS that existed earlier, but then try to make it vendor agnostic. And you also try to separate out the infrastructure part on which you're going to run all these components from the actual network functions. So how did this go? So the earlier we had, this is more or less how the RAN was stacked. And we said that we want to disaggregate. So how are you going to disaggregate out here? There are already several ways described in 3GPP called splits, and there are several options like option 8, option 7, option 6, option 5, so on and so forth. But then we need to decide on what is the standardized split everyone is going to do, so that we have lesser interop issues and standardized way of interworking between the various components. So we started with let's start from the bottom. So you take the radio and a part of PHY, and now we call this, because it's more towards the radio, we call it lower PHY. That becomes something we call as ORU, the ORAN RU in the ORAN terminology. Then you club in the timing critical part and put it in ODU, the O distributed unit. Distributed because this is something which is which drives data latencies and more critical towards the edge applications. You can push it out towards the edge cloud. And then you have a centralized unit that aggregates the control plane traffic, as part of user plane 2 out there. And then, so we said, okay, let's split that and then make it a user plane and control plane. And then we deploy this control plane much away at regional clouds and the user plane mode along with the DU so that it scales better with the traffic. So this is all fine. And one of the points which I mentioned, the more components you bring in, so the red arrows which I try to put, those are the interfaces which needed to be standardized. And now this becomes the charter of the ORAN, right? So what we want to do is standardize these interfaces standardize these components and standardize how these components are going to play. Of course, yeah, one needs to bring in some sort of intelligent management system, what we call as the RAN intelligent controller. So put all this together, we would form what is there in ORAN. So I just try to list out what the RAN intelligent controller provides you. More of a management framework. It brings in its own AIML technique deployment methodologies with several feedback loops, but the feedback loops are at various time granularities. So you need different types of loops. If I put all this again, so things, the ORAN architecture would look more or less like this, right? So you have the platform, which is agnostic to the applications which it's deploying. Then you have the ORU, which is a physical function. Then you have ODU, the distributed unit, which I mentioned. Then it's UUP, UCP, and the RIC, etc., etc. Plus, at the same time, there are interfaces you see out there, the E2, E1, F1, O1. There are a handful of them, right? And then this figure indicates that where the control loops are and what we are going to, what are their time sensitivities, etc. And that's more or less. So most of the standardization activity that goes on along these aspects. That what are the components, what are the interfaces, and how is the management. And with this, we have several work groups that get created. There's work group 1, work group 2. We'll see what these names are. And there are certain focus groups when it comes to doing a particular part, which goes across several work groups, but is more to make a minimum viable product. So what are the work groups? The hierarchy is pretty flat. So you have technical steering committee and you have all these work groups. So the WG1, what we call, it's more on defining the use cases and deployment scenarios and how the overall architecture would be. So this is similar to the SA groups which you see in 3GPP. These also, it's like SA1 and SA2 merged together, right? And then within that, you have the architectural subgroup. There's a network slicing technology group. There's a use case technology group. And so these are the three which are prominently up there. Once we have, then there is the WG2 talks about the non-RT RIC controller, their interfaces, their architectures, and what are the use case models out there. Similarly, the WG3 talks about the near RT part, the one with sub 5 millisecond latency loops. There's one work group which is peculiar out here, the WG4. Right? So from here onwards, the couple of work groups they define, they work more on the interfaces. But then ORAN front hall, one that connects your RU and it's such an important interface that it warranties its own subgroup out here because it's related to performance management and how you're going to use the transport, all the stuff together. So this, if you were to look at the whole stuff more from a RAN perspective, I would say this is the most critical work group to focus on. Then there's a WG5, which defines all the interfaces like F1, W1, E2, X2, and all the stuff. You see the O interface is missing out there. They are taken as a different part. So these are the interfaces between the various network element functions. And beyond this, you have the cloudification and orchestration work group. This is what we are primarily part of. And the mandate of this group is to define a cloud architecture on which you can host the ODUs and OCUs. At the same time, how do you handle the accelerated functions, or how do you standardize the interfaces to the accelerated functions? So, probably you guys may be aware, not aware. Although we moved everything to COTS hardware, there are few things which cannot be done efficiently on COTS, and more because doesn't meet the deployment constraint for power and compute capabilities and so forth. So there are specialized things which are still in specialized hardware. And then if that needs to be cloudified and that needs to be shared across several instances of a DU, then how do we achieve this? So there are profiles defined out here on how you share it. There are deployment models defined based on Kubernetes and HCNFV stack to take care of this. So primarily, other than the WG4, WG6 is another key role that defines the ORAN or the cloud native deployments. Defines standard white box architecture. This includes the components, schematics, list everything which one can use to build your own boxes. And there's a stack reference design. I think there's a lot of participation from, I see from XPL, there's a lot from Wipro and other companies that goes in here, and a lot of the work that goes in WG8 that gets replicated on, or what do you say? It takes life on the ORAN SC repositories where you build a reference design to showcase what's going on here. There's WG9 on open fronthaul transport, then WG10 for O&M. This is another interface which is critical for deployment. And then this is a relatively new, the security part which has come into place. And that's all, more or less. Within these 10 groups, we achieve all the stuff that needs to be specified for a cloudified and open network architecture. Or the stuff is governed by a technical steering committee that oversees what work groups or special interest groups need to be formed out there. And then usually when you start off a new work item or work group needs to be approved through the TSC and WP1 because it fits in the architecture. And then you go down sketching out all the details. So how does that one contribute? Subhash mentioned, it's not open for all. It's both academic institutes which have to be a member of ORAN and they can participate in weekly meetings through bringing in the contributions, CR, etc. So there's another part on ORAN SC. These are the reference implementations which I mentioned on the WG8. There you can bring in your software components, enhancement proposals, and they get discussed in the forum, and then on basis of technical merit, the PR get merged or rejected. So that's all. I think I have 10 minutes. I did it in 10 minutes, hopefully. If there are questions, probably we'll take it up with all the guys who are sitting out there. Thank you.